80 million years ago, the Earth was a much warmer place. The recent breakup of Pangaea had unleashed a surge of volcanism across the planet, packing the atmosphere with carbon dioxide at over 1,000 parts per million, or more than twice what it is now. These greenhouse conditions sent jungles sprawling as far as the poles and left many animals without the need to produce much of their own body heat. Freed of this burden, a class of mesothermic reptilians were able to spend more of their energy on growing larger than any animal ever had before, becoming what we know now as the dinosaurs. The tremendous size of these creatures is what allowed them to dominate the Earth's animal communities for over 170 million years. In that time, the dinosaurs were constantly evolving as necessary in order to maintain their dominant status, in effect producing an incredibly diverse collection of specimens that paleontologists are still piecing together to this day. Because of this, our knowledge of dinosaurs can never truly be considered complete, but we can definitely use the picture that's emerging to better understand how life on Earth has progressed to get where it is now. But here's the problem, I don't actually know that much about dinosaurs. I mean, even as a kid, I was never really interested in them, as it always just seemed like memorizing a bunch of different animals, without any sense of why it mattered or how it even related to today. When I got to college, I was taught to think in terms of systems, like Earth systems, ecosystems, climate systems, planetary systems, whatever. And so learning something without any sort of framework, like learning all the different sorts of dinosaurs, always felt less like knowledge and more like information, if that makes sense. But you know what? Now that I've been through college, maybe it's time that I look for the underlying structures of dinosaurs myself. After all, dinosaurs are some of the most utterly amazing animals that have ever walked this earth. And so I'm sure if I just understood them better, preferably through something visual like geography or even better biogeography, then I could really learn to appreciate them. So that's my goal for this video, to build for myself and for all of you the basic framework to understand these creatures and their evolutions both over time and across continents, so that going forward I have the knowledge to make more videos on these wondrous creatures that were the dinosaurs. The story of the dinosaurs starts over 200 million years ago on the supercontinent Pangaea. As I explained in my 7 Realms of Biogeography video, it would be from this landmass that the continents of today, and by extension their distinct floras and faunas, would later all delineate from. At the time, however, Pangaea's connectedness allowed for a more even distribution of species across the planet, resulting in one unified global plant and animal community, or in other words, just a single biogeographic realm. While the earliest dinosaurs may have emerged as early as 240 million years ago, at the time the dominant creatures of the Earth were massive amphibians like Temnospondyli and large reptiles like Phytosaurs. And it wouldn't be until the Triassic-Jurassic extinction event around 200 million years ago, roughly coinciding with Pangaea's formation, that a worldwide dying of these sorts of animals opened the door for dinosaurs to assume the role of dominant animals on the planet. Being this early in their evolutionary history, however, there were only 2 main branches of dinosaurs to begin with, the Saurischians and the Ornithischians, both of which were predominantly herbivores because, well, these guys were the carnivores. But without many predators carried over from the Triassic, it was only a matter of time before a dinosaur came in to fill the void. From the Saurischians, a group known as theropods quickly diversified into a mainly carnivorous role, while what was left of the Saurischians became the herbivorous sauropods, establishing a single prevailing food chain across the whole Pangaic realm. But as we all know, Pangaea would eventually start to crack, with the first break coming in the division of North and South, Laurasia and Gondwana. And as the divide between these 2 continents widened, so too did their animal communities. Across what's now North America, Europe, and Asia, sauropods were mostly outcompeted by the Ornithischians, which gave them the space to diversify into a variety of forms. While I definitely can't mention them all, some of the most common, both in the fossil record and in media, would be Hadrosaurs, or the duck-billed dinosaurs, which I've heard described as the cows of the Cretaceous, iguanodons, which to be honest are some of the more basic dinosaurs, ceratopses, or the horned-faced dinosaurs, I guess making them the rhinos of their time, Ankylosaurs, the absolute units of the dinosaur world, which grew hard plates of armor on their exteriors, and Pachycephalosaurs, or the dome-headed dinos, using their thick skulls presumably to battle one another like mountain goats of today. Laurasian theropods, on the other hand, branched off into dromaeosaurs and tyrannosaurs. Contrarily, on Gondwana, it was the sauropods that came to dominate within the herbivorous arena. However, unlike the ornithischians, which developed into a wide range of body shapes, sauropods took the more if it ain't broke, don't fix it approach, and mostly maintained the same basic structure across all the different species that arose from this group, no matter how diverse they became. The same can be said about the theropods, which despite branching into abelisaurs instead of tyrannosaurs in Gondwana, appeared virtually identical to them. Overall, this left Laurasia with an apparently diverse array of ornithischian herbivores, and Gondwana with a seemingly less diverse herbivore communities of primarily sauropods, both still being preyed upon by theropods. These differences were only exacerbated by the continued fracturing of the lands at the dawn of the Cretaceous period, allowing the individual continents to begin developing their own unique dinosaur faunas. With dinosaur populations becoming more and more isolated, they needed to continuously evolve in order to maintain their dominant status, causing their diversity to peak somewhere between 80 to 66 million years ago during the late Cretaceous. Not coincidentally, this is the time period when most of the dinosaurs you and I are familiar with roamed the Earth, so that's when we're going to be focusing on. Although no single map can represent the Earth over a span of 20 million years, to make things simple, we're going to pick just a single frame from this animation to represent the Cretaceous period. The frame in question is this one, which represents roughly 80 million years ago. My reason for choosing this specific time is that it's the last frame in this animation before this large circular structure suddenly forms in what's now part of southern Mexico, which I'll explain later why it's so important. By this point, all the continents we know today had managed to separate themselves from one another, but only barely. On top of this, the exceedingly high temperatures of the late Cretaceous combined with widespread volcanism building up the ocean floor drove sea levels far above where they are now, leading to many landmasses experiencing widespread flooding across their low-lying interiors. That's how we ended up with a North America broken into three pieces, held up on the east by the ancient Appalachian Mountains, to the north by the lands that would eventually form Greenland and the Canadian islands, and on the west by the Rockies, which were at this time entering a new phase of rapid growth, what's known as the Laramide Orogeny, or in simple English, the Laramide mountain building process, giving the landmass its name, Laramidia. Situated like this, Laramidia stood to receive genetic influx both from Appalachia as well as from Asia, positioning it to amass a huge animal community more diverse than anywhere else in the world. Here, all of those groups of ornithischians were represented by ankylosaurs like, Ankylosaurus, ceratopses like everyone's favorite Triceratops, plus many more, hadrosaurs like, take your pick, and pachycephalosaurs like, Pachycephalosaurus. On top of this, while the great success of the ornithischians here definitely overshadowed sauropods, this did not mean they went extinct here and were also around in forms like Alamosaurus. Between the two carnivorous theropods of Laurasia, Tyrannosaurus won out here, the largest species of which being, Tyrannosaurus rex, among many others like Dinosaurs. Altogether, the fauna of Laramidia during the late Cretaceous represents the most well-known cast of dinosaurs in the world, despite for the most part only living here in western North America. Even in Appalachia, Laramidia's closest relative, both geologically and biologically, such high levels of diversity are not seen in the fossil record. While there were some tyrannosaurids like Dryptosaurus, these were all far smaller than their Laramidian counterparts, giving the dromaeosaurs the opportunity to share in the top carnivorous role. The hierarchy of herbivores also varied between the landmasses, with Appalachia lacking notable numbers of ankylosaurs, pachycephalosaurs, and ceratopses in exchange for a more widely diversified group of hadrosaurs like Claosaurus, Lopherhothan, Hypsibema, Eotrachodon, and of course Hadrosaurus. With this assortment of species, the faunal community of Appalachia more closely resembled the scattered islands of what's now Europe than Laramide, which makes sense considering their not so distant breakup and their isolation from Asia due to much of what's now Russia being completely underwater at the time. And lastly, for North America, we have this northern landmass. Unfortunately, we don't actually know that much about this place. Heck, I couldn't even find a name for it. I mean, going back in time, we can see that for most of its history, it was either connected to Appalachia or North America as a whole, and only appears separate in this single frame, suggesting it too would have closely resembled the animal communities of these lands, probably not even having the time to develop into its own distinct biota, but rather belonging to the greater Appalachian realm. But here's the thing, we really just don't know. Fossil discoveries from this part of the world are scarce, partially due to the fact that barely anyone lives here now, but even more so because of what these lands experienced only a few thousand years ago, having been covered in massive ice sheets several times over, with Greenland even remaining covered to this day. The destructive nature of these glaciations have in effect erased much of the fossil record here, meaning we can only guess as to what the species makeup of this land was. Given the brief history of this landmass and the lack of fossil specimens, not much more can really be said about it. But don't worry, in a field like paleontology, knowing what you don't know is equally important, if not more important, than knowing what you do know. As the only way to make a discovery is by taking something from the unknown into the known, and to do this, you need to know where to look. But even without knowing much about this one landmass, the picture that's emerging is one of a North America that hosted a highly diverse ecosystem. Okay, where were we? Oh, that's right. Looking back to Laramide, we can see that it was actually in closer contact with the northeast of Asia at the time, with the two continents even periodically reconnecting to each other, sometimes for tens of millions of years, leading these two lands to share in an apparently closer relationship than with Appalachia. This explains why it was here that we'll find a similarly diverse ornithischian fauna consisting of Ankylosaurs like Minotaurosaurus, ceratopses like little Protoceratops and more, Pachycephalosaurs like Prenocephaly, Hadrosaurs like Olorotitan and Shantungosaurus, along with, sure, even some sauropods like Asiatosaurus. All of which were, yes, being hunted primarily by tyrannosaurs, though these too were smaller than their Laramidian counterparts, coming in the form of Alioramus, Zhuchengtyrannus, and Tarbosaurus. Looking at these 3 or 4 continents, we can already see the biogeographic realms of today taking shape, evolving apart from one another while simultaneously remaining more related to each other than the rest of the continents further south. If you'll remember, across the Gondwanan lands, it was the sauropods that managed to outcompete most ornithischians for herbivorous dominance. As a result, the incredible diversity of ornithischians in the north was not present here in the south, but rather we'll find many different, though let's be honest, to the untrained eye, identical sauropod species. Across South America, for example, which had just barely managed to stay in one piece and played host to a tremendous inland sea, a large number of sauropods like Antarctosaurus, Dreadnoughtus, Tralcutitan, Feudalonchosaurus, Rankensaurus, Saltosaurus, and the biggest of all, Argentinosaurus roamed, while the ornithischians were only represented by a handful of hadrosaurs and iguanodonts. Hunting these were not tyrannosaurs or even dromaeosaurs, but their theropod cousins, the abelisaurs, like Scorpiovenator and Carnotaurus. We can think of this as the blueprint for all of the animal communities across the Gondwanan continents, like Africa, which had only been separated from South America for 20 million years at this point, leaving the continent with a familiar diet of sauropods like Egyptosaurus, Paralititan, Rabacosaurus, and Molluosaurus, along with a reduced selection of ornithischians, again limited to hadrosaurs like Ajnabia and iguanodonts like Elrazosaurus, all being preyed upon by abelisaurs like Chinanosaurus. But here's where things get interesting, as these weren't the true kings, or I guess rexes, of the African realm, having been locally usurped by even larger theropods known as Spinosaurs, with members like Sigilomastosaurus and, yes, Spinosaurus. Estimated to have been potentially bigger than even a T-Rex, answers as to how Spinosaurs got so big can also help explain why they look so different from the other theropods we've seen so far. You see, spinosaurs were believed to have been partially aquatic creatures, with their buoyancy in water helping to take some of the weight off, allowing them to grow bigger and selecting for more muscular tails to help them paddle through water. A potential reason these theropods evolved into the water could be that, similar to North America, Africa was also fractured as a result of the particularly high sea levels of the time, with a narrow and shallow inland sea crossing between east and west. Having formed nearly 30 million years prior, this divide between the two halves of the continent was present for nearly the same amount of time as the western interior seaway that split Laramidia from Appalachia, suggesting the possibility that these two landmasses could have formed their own distinct realms for a time. But to be honest, I just couldn't find enough evidence to support this. Perhaps the narrower inland sea allowed for easier crossing between the two African fragments, or perhaps the sea was shallow enough to form temporary land bridges, or, and in my opinion most likely, perhaps just not enough fossils have been found in Africa to actually help us differentiate the two lands yet. The fact of the matter is that while dinosaur mania swept through North America, fueling a huge number of discoveries, even something called the Bone Wars, Africa at the very same time was being colonized, and well, it wasn't fossils that the colonizers were after, leaving many places like Africa and elsewhere around the world drastically understudied. I mean, just look at how short the list of known African dinosaurs is compared to the list of known North American dinosaurs. It could very well be that we just have more data on places like North America and Asia. And with time, as more details are uncovered and discoveries made in places like Africa, the big picture could change. Or not, I don't really know, but that's part of the beauty of paleontology. We're not even close to knowing all the different genuses of dinosaurs, let alone species. And all it would take is a handful of dedicated scientists to completely alter our understanding of them here. The story is again the same for India and Madagascar. It was together that these lands broke from the rest of Gondwana 40 million years before our final map, and only separated from each other 20 million years later. This means that while potentially enough time had passed for the fauna of the two landmasses to have diverged slightly from other Gondwanan animals, not enough time had passed for any significant difference between them to be found in the fossil record, and so they could still be considered a single combined realm. Unsurprisingly, here we'll find a classic Gondwanan animal community, where sauropods like Brachiosaurus, Isosaurus, and Dinosaurs served as the only known herbivores during the late Cretaceous, all being preyed upon by abelisaurs like Rajasaurus and Majungasaurus. Finally, this brings us to the southern continents of Antarctica and Australia, which had also been combined for most of the dinosaurs' reign on Earth, and were only in the early stages of breaking apart by this time. Like India and Madagascar, the recent attachment of these two continents means their related animal communities could not have substantially diverged from one another yet, and the lands could have been considered under a single Australic realm. Unlike today, the South Pole of the Cretaceous was bathed in the excess heat of a greenhouse Earth, allowing forests to cover the two continents wherever there was enough water to do so, in turn sustaining communities of sauropods like Diamantinosaurus and Savannosaurus, alongside a small selection of ornithischians, with ankylosaurs like Antarctopelta and iguanodons like Trinosaura and Morosaurus. However, since then, huge ice sheets have piled on top of the land, making recovering most Antarctic fossils impossible, leaving the fossil record for this southern realm far more incomplete than any other. As such, the only carnivorous dinosaurs known to have lived here during the late Cretaceous were Imperobiter and Australovenator, both only small to mid-sized theropods that were likely not the true apex predators of the southern lands. Altogether, what we can see from this is that while the specific species of a continent varied, they all followed the same structure that was established all the way back in Pangaea. As it stands now, it appears that dinosaur diversity peaked in the western half of North America, though in time the dinosaur communities of all the continents could have diversified to a similar degree. Except, as we all know, the time of the dinosaurs was cut short, as just a single frame forward, and again, this small circular feature appears towards the south end of Laramidia. This is the Chexalub impact crater, created 66 million years ago when an asteroid 6 miles in diameter came crashing into the Earth, putting an abrupt end not only to all of the dinosaurs mentioned in this video, but also to the Cretaceous period as a whole. The only dinosaurs to survive this event were a small group of theropods known as the avians, the ancestors to all modern birds. But lucky for us, life is never done evolving, and the extinction of the dinosaurs left a hole in the Earth's ecology that would eventually come to be filled by mammals. So there you have it, the story of the dinosaurs from beginning to middle to end, a 170 million year long experiment in biology. With such an extensive natural history spanning 3 geological periods and including possibly millions of species, it's easy to get lost in all of that information. Was I able to mention all of the dinosaurs? No, not even close. Heck, I didn't even get to mention all the crazy stuff that was going on with plants at the time. But I hope I managed to take the big picture and condense it into an understandable narrative from start to untimely finish. And that's what I find so interesting about the dinosaurs. Unlike most other species that either gradually go extinct with the changing conditions of the time or evolve into a completely unrecognizable shadow of their former selves, in the case of the dinosaurs, the never-ending story of evolution was actually put to a very distinct end and can be viewed as their own separate chapter within the overarching story that is life on Earth. Actually, you know what? I think I'm going to do the outro like this too. I hope you enjoyed, and if you did, of course, if you'd like to support me and the channel, then there should be a link somewhere on screen to go to my Patreon. Oh, and what did you think of seeing my face? Did you like it, or should I go back to not having a face? Let me know. Let's see, what else? Oh yeah, if you want to see more biogeography, then I'll put together a playlist for you that should be on screen somewhere here. Other than that, like, subscribe, and thanks for watching.